Hey, my name is Scott Lydon, and you're watching Swifty. In a previous video, we made a Pokedex app, and you might have noticed that the Pokemon were not ordered. Charmander was coming after Bulbasaur. Charizard was coming before Charmander. In this video, I'm going to show you how the sort method, which takes a closure, can be used to concisely sort the Pokemon. Also, you may have noticed that the Pokemon were not capitalized. I'm going to show you how we can use map to capitalize each of the Pokemon. Let's address the elephant in the room, which is how much it sucks that those Pokemon are not sorted. So let's use closures again to manipulate that. So let's say self.pokemons, and I'm going to use a method that takes a closure, a method on arrays and collection types that takes a closure, and we've already gone over it. It's called sort. So I'm going to do sort, and now how do I want to sort it? Basically, I want to sort it by number. So I'm going to use the shorthand that comes with the sort function, and I'm going to do number. Because remember, when I do $0, what is it representing? It's representing a Pokemon. So I'm going to do number is less than, and it's representing a number that's right up against, it's going Pokemon by Pokemon. So let's say we have Bulbasaur, and it's going to be mad at me because I haven't defined all these terms. So let's say we have a Bulbasaur, a Charizard, and Pikachu. And so when we do 0 and $0, and then when we do $1, first it compares Bulbasaur versus Charizard. Then it goes to the next one, Charizard versus Pikachu. And it's really kind of an unoptimized description of it, because what I'm kind of describing is like a bubble sort where it goes through several times and swaps until finally it doesn't need to swap anymore, and then it moves on. What it's actually using behind the scenes is something called introsort, which is a highly optimized hybrid sorting algorithm. It's one of the fastest sorting algorithms known. When I do $0.0.number is less than $1.number, I'm basically saying arrange this array so that the lower numbers move to the left and the higher numbers move to the right. So if there are two numbers next to each other, the one on the left will be lower than the one on the right. And that's what it should do, and let's run it and see what happens. So as they're coming in, they might not come in order, but as they come in, they will be ordering themselves. I'm going to stop this. And one other thing that's kind of bothering me is that I want to see the Pokemon capitalized. They weren't coming in capitalized, they weren't displaying capitalized, so what I'm going to do to the array is I'm going to do self.pokemons and equals self.pokemons.map, and I'm going to return, for each Pokemon that comes in, I'm going to return, an instantiated Pokemon, and for the number, I'm just going to give it the number that it comes with, but for the name, I'm going to make it capitalized. Alright, so basically this goes through each of the items in the array. So I'm going to do the same kind of example here. Bulbasaur, I apologize if I'm spelling them wrong. Pikachu, making many Pokemon enemies. Okay, so the way that this map function passes the closure through is it looks at one item at a time. You can think of it this way, and so then it says, okay, Bulbasaur, we're going to take this Bulbasaur and then we're going to create a Pokemon, and we are going to keep its number the same, but then we are going to capitalize its name. So then if we had an array of just the names, then you could think of it as doing is taking Bulbasaur and then capitalizing the first letter and then returning that version. and then Charizard, capitalizing the first letter and returning that version. Pikachu, capitalizing the first letter and then returning that version. All right, so let's see it in action. Now, these, sometimes this database acts up. I'm just going to give it a minute. So, map, filter, reduce, sort are all very useful for interview questions because they can help you it takes away 10 minutes of reinventing the wheel. And when you're given an algorithm challenge, 10 minutes counts for a lot. And to not have to reinvent the wheel, that's a nice blessing. So map, filter, reduce, sort, all useful. Also note that there's sort, but there's also sorted. So I'm going to change that to sorted. And it's going to give me a yellow warning. And it's going to say the result of call to sorted by is unused. And that's because when you use sorted, it actually returns an array. When you do sort, it just changes the array in place. So when you do sorted, it creates, it allocates memory for a new array that it creates. And then when you do sort, it only changes the array that you give it. It doesn't create another copy of it. So that's another useful thing. Sometimes algorithm challenges will include sorting an array in place by different constraints, and that can be very useful.